All right, this is Module 5, Lesson 15. We have talked already about random sampling and what it is, that every option has an equally likely chance of being picked. Now we're going to be looking at how we can find a random sample. We're going to design a plan to select it to answer any statistical questions about a certain population. So this data right here is a bunch of children's books, and it tells us how many words are in each. You can look to see, like, The Hobbit has, where am I looking here? The Hobbit has 95,022 words. The Cat in the Hat, however, has 830 words. So popular books vary, just not the number of different words, but the number of total words. Okay, so here's our diagram. Now, if you flip the page, it's going to give us a histogram that represents 150 of these books. Now, remember, to read this histogram, that would be 25 books, or just over 25 books, would have between 0 and 5,000 words. 20 books have between 5,000 and 10,000 words, and so on. So from the table, we're going to choose two books with which you are familiar. You're going to describe the location in the data distribution shown in the histogram. So let's use A Cat in the Hat. All right, I'm going to go back and look at it has 830 words. So 830 words would be between 0 and 5,000. It would fall in this category right here. All right, how about, let's pick, actually, why don't we just pick The Hobbit that we had before? So The Hobbit has 95,000, I think it said, 95,022. So if you're looking at that, it would be between 95,000 and 100,000. So that would be in this one right here. All right, it says put dots on the number line below that you think would be a random sample. So choosing just size 10, so 10 books from that list, what do you think the dot plot would look like? Now look, this is your population. So when we're drawing from this population, you have to make sure it represents this population, because remember from yesterday, all samples resemble the population you're choosing from. Now, there's a lot of books that have 0 to 5,000, and then a lot that are heavy on this side. So when you choose your 10, you're probably going to have more dots on the left and the right than in the middle. Now, if you're looking at this between 15 and 20,000, there's no books. So you shouldn't even have any dots between there. So I'm going to choose, let's see, I'm going to do 2 dots there. How about 4, 5, 6, 7. I'm going to choose one from the 40,000. That's 8. Okay, I'm going to do 9. And I need one more. How about right around 75,000? So if you look at my dot plot, first of all, will it be the same as what you choose? No, probably not. It will be similar, though, because we're pulling from the same population. So it should look like that histogram up above. It says, how do you think the sample distribution would look if you were allowed to pick your 10 favorite books? Would that be biased? Well, probably, because it depends what kind of books you like to read. Maybe you would be reading very short books. Maybe you would be reading very long books. So this would not be good if you just got to choose your 10 favorites. So this would be biased. For all the reasons that we just said. Okay. It would not, every book would not have a chance of being picked. Okay, so what I'm going to do is I'm going to take you to example 2, and I'm going to show you a way that it would not be biased. It would be a random selection of these books to figure out what is the typical number of words in children's books. Okay, so that's our question that we're asking. It says, answer this question that would involve collecting data. and there would be a variability in those data. Variability just means that your samples that you pick will always be similar, but not the same. So this makes the question a statistical question. So let's think about the 150 books used to create the histogram on the previous page as a population. So that's all books. How would you go about collecting data to determine the typical number of words for the books in the population? So let's brainstorm some ideas. Obviously, we can't just select our favorite books. That would not give every book a chance of being picked. But what about labeling all the books 1 through 150, putting them in a hat and selecting them right out of the hat? That would be a random sample. Let's do that. Place the numbers 1 through 150 on sheets of paper. And draw out of a hat. So how would you choose a random sample from the collection of 150 books discussed in this lesson? Well, that's kind of what we were just talking about, right? We're going to label them all 1 to 150, and we're going to randomly choose them out of a hat, okay? So we could write that we're going to assign each book the number 1 through 150 and select out of a bag. Same idea, right? All right, so here is actually the list of the data for 1 through 150. Now let me show you how this works. This would be book 1, 2, 3, 4, and it goes all the way up to 10. So the next row, this is 11 through 20. So 11, 12, 13, 14, and so on. So if you go down to here, this would be 91, 92, 93, and so on. So this is a list of all the books and how many words they have. So step 3 says, let's follow my instructions to generate a list of 10 random numbers. We're going to find the total number of words corresponding to each book identified by your random numbers. Now, another way to do this is actually to use a computer-generated program where I enter all the data in there, like 1 through 150, and I just hit go. And it say I want 10 random numbers, the computer will give me 10 random numbers. We are going to do that in class. So there's, unless you Google search a random number generator, you could try it at home. But we are going to do this in class to find the 10 random numbers. Now, the next part says, if you were to compare your samples to a classmate's sample, do you think your samples would be fair or would be similar? And the answer would be yes, because all samples are going to be similar. They're coming from the same population. But will they be the exact same? No. All right, we're going to do this again using the random sample. We've already done it once. We're going to do 2 more, and we're going to make a dot plot of all 3. So if you can use the random number generator again to make your dot plots, you're going to line them up so that this is sample 1. This is sample 2. And this would be sample 3. Now, when you have 3 dot plots like this, the 0 is just going to go all the way up. This would be 20,000, 40,000. So all the dot plots are going to be right on top of one another so that you can compare. Now, we started talking a little bit about what happens if we increased our sample size with the Skittles in class. And we said, okay, we took just our individual packets, which only had about 20 Skittles. And then we had all the results of our whole table, which is more like 80 Skittles. And then we talked about what if we took the whole class sample. Now, as your sample size increases, we're hoping that your numbers get closer to the actual average. So it says select 10 more books from the list and add them to your original dot plot in a different color. Once again, we're going to do that in class. And how do the different samples compare after the addition of 10 more books? So now, as we're increasing in size, it hopefully should be getting closer and closer together. All right, and that's it for this lesson. You can try the problem set that is on the very next page. Have fun.